Good morning, Year 10. Going to go through page 5 of the Algebra 3H pack, and this page is all about something called the difference of two squares. It follows on from the factorising we've been doing on the previous pages, and specifically quadratics. So I've shrunk the title down a little bit and added this diagram just to try and help explain this. Let's say we wanted to find the shaded area of this shape here. Now, it's a square. The large red square is a square with area of a squared. And this square has been cut out the corner, and if we give that side length called b, then that would have an area of b squared. So the area here is a squared minus b squared. But if we rearrange this, if we use this section here that I've just sectioned off with the green dotted line, and we bring it down underneath the shape and rotate it and add it onto the bottom, I think you'll see that this length here is the same as this length here. Both of those lengths are a minus b. So this new shape has the same area as the shaded shape here, but it's just a rectangle with a width of a minus b, but its height is now a plus b. And therefore we can say that a squared minus b squared is equivalent to a plus b times a minus b. And this is what we call the difference of two squares, because the difference is what you get when you subtract, and we started with two squares. Okay, it's something to watch out for when you're factorising, because up until this point, if we'd have been asked to factorise something that only had two terms in it, we'd probably think it was just a single bracket factorisation, but actually these ones are double brackets as well. You don't have to remember all of this to be able to do it. A little hint I like to use is to think of this as a three-term quadratic, so x squared plus 0x's minus 16. Of course we wouldn't normally put this, but it's going to help us to think about it the same way we have done above. So we're looking for two numbers. Of course the first two terms are going to be x. We're looking for two numbers that are going to times together to make negative 16, but add together to make 0. And if they add together to make 0, that means they're going to be the same number, just one positive, one negative. Okay, and if you think about a number that times us by itself to get 16, that number is going to be 4. So one of them has to be positive, one of them has to be negative. Doesn't matter which bracket is your positive one and which is your negative one. But you'll soon notice that this number here, the second number in the bracket, is always the square root of this number here. Okay, one easy way to spot questions involving the difference of two squares is that you're always given square numbers usually. Okay, so on this next one, we'd look at that and we'd think, oh, this is a square number, this is a square number, so this is the difference of two squares. So in my brackets I'm going to have x to get that x squared term, and then I'm going to have a plus 5 and a minus 5. And just to show you that this works when we expand out, I'll just do it on this one. So if we do FOIL, first times first, we would get x squared. Outer ones times together would give us minus 5x. The inner ones would give us plus 5x. And hopefully you can see that those two are the ones that are going to cancel out. And then when we times the last two, we would get minus 25. So these two middle ones would cancel out, and it would give us x squared minus 25. Okay, on to C. Actually, I'm not going to do all of these. I will pause the video now and you can do them and then mark your work. Okay, there's the answers to question 1. The only one that was slightly different from the others was this last one. It just involved a letter here, but that's a square number whose square root is just b. So it was just a case of using b instead of a number like we have done on the other ones. Okay, on to question 2. Question 2 is solving quadratics again. We don't even really have to consider that this is about the difference of two squares, but these are similar to the ones we've done above. So we've done lots of solving quadratics so far. We know that for this bracket to be 0, x must have been 1. And for this one to have been 0, x must have been negative 1. Okay, so I'll fly through these answers. On this one we've got solutions of x equals minus 2 and x equals positive 2. And on this one, x equals 9 and x equals negative 9. Okay. On question 2, we're going to have to factorise these first and then solve them. So it's just very similar to the pages above, but obviously involving the difference of 2 squares. So this one will be x plus 3 and x minus 3, and that means our solutions will be x equals minus 3 from this bracket and x equals positive 3 from this bracket. Okay, just the only ones to watch out for on this question are the fractions. It might seem like a fraction is not a square number, because we normally say that a square number is an integer, but if we think about what we could square to get 1/9, then we can square root it. We don't have to have a square number to be able to square root something. I'm just going to do that. So in our brackets for this one, have a little think. What would we times together to make 1/9? What do we times by itself? Well, if you remember multiplying fractions, the top numbers will always times together to make the numerator over here, and the denominators will times together to make this denominator. And if they have to be the same, obviously they're going to be the square root of 9 themselves. Okay, so this is x plus 1/3 and x minus 1/3. And then obviously we need to go and solve that. So x is equal to negative 1/3 and a positive 1/3. Okay, I'll just quickly talk about question 3 as well, and then let you have a go at all of those in one go. The only difference on these ones is that we're using 2 letters for our terms rather than just a constant term, but some of those letters have coefficients. I think you'd probably be able to work this out for yourself, but I'll explain it nonetheless. It's still, those coefficients will still probably be square numbers. Okay, so you can just square root themselves. So this one would be x plus 2y, because 2 is the square root of 4, and this one will be x minus 2y. And if you're not sure why that still works, try expanding it out and you will see. Okay, question 4, very much the same as question 3, except it's a solve question. The only one different on this page is these last 2 questions, which I'll go through in a minute, but for now I'll pause and show the answers to questions 2, 3 and 4. Okay, there's the answers to question 2. Question 3 and question 4. Oops, don't want to show question 5 too soon. No, there's no way I can't really. I'll explain question 5 in a second now. Okay, just watch out for these ones where you do have a number in front of the x. Remember, they're a little bit harder to solve when you've just got your brackets. I would actually write an equation out and then solve from the equation. And leave them as fractions as well, they're much easier. Okay, let's have a look at questions 5 and 6. Question 5 doesn't look like the difference of 2 squares. These are not square numbers. So where would we start with this one? Well, at the moment this looks like just a single bracket factorisation. So that's the route we're going to go down. We look for a common factor, highest common factor of both those terms, and that is 5. And now if we take that out as a common factor, we're left with 4x squared minus 1. And it's about being able to then spot that that in itself, inside the brackets, is a difference of 2 squares, and therefore can be factorised further. So this is 5 lots off. I'll keep that 5 there for the moment. And this will form its own double bracket now, where we have 2x at the start of each, because that will give us the 4x squared, and we have a plus 1 and a minus 1. And that is the fully factorised answer. And question 6, it can be shown that a squared minus b squared is this. This is just stating the difference of 2 squares. Hence, or otherwise, simplify fully this expression. Now, it looks complicated because there's loads of things going on there, but if we just treat this bracket as a and this bracket as b, then what we've got going on there is this, a squared minus b squared. So we're just going to copy this part of it and use a and b instead of a and b there. Okay, so I'm going to put my a value first, so I'm going to put the whole thing, x squared plus 4, and then we're going to take away whatever my b was. So I'm going to take away, and when I take away what b is, I need to just bear in mind that there's already a subtract here, so I'm going to end up taking away x squared, and then I'm going to end up taking away -2, which would give me a plus 4. Okay, that's that first a minus b done. Now we're going to do a plus b. So I'm going to put my a again, x squared plus 4. And I'm going to add x squared minus 2. So now to simplify those brackets, in this first one I've got x squared minus x squared, and they're going to cancel out. But I do have 4 plus 4, and that will give me 8. In my second bracket, I've got x squared plus x squared, so I've got 2x squared. And I've got a plus 4 and a minus 2, which will give me a plus 2. And to simplify this fully, I could either fully expand it out, and that would give me 16x squared plus 16. Or I could leave it in factorised form, but the form above is not fully factorised. I can take out another factor of 2, or I could just factorise this and say that that is 16 brackets x squared plus 1. Okay.